Welcome to Brain Vision.
In this question, we are given a graph of kinetic energy versus position for a small sphere of mass m experiencing a single conservative force as it moves along the x-axis. And we are asked about a number of questions about its potential energy. So first we're asked, is u of x symmetric about x equals 0? Well, to answer that, the first thing we need to consider is that we're going to assume energy is conserved, which means we're going to assume that k plus u equals a constant value. And given that, since k is symmetric about x equals 0, u will be as well. And next we are asked, if we set u equals 0 at x equals 0, then what will be our value of u at x equals negative 1.5 meters? So I think the important thing is to consider, what helped me understand this is to think, don't worry about setting u equals 0 at x equals 0 at first. If u equals 0 when when k is maximum, let's start with that to help us figure out what the values would be, and we'll go from there to figure out what they are if u is 0 at x equals 0. So if u equals 0 when k equals max, well, first of all, our k equals maximum has a value of 0.39 joules. And then we have this local minimum here where k at 0 has a value of 0.14 joules. So if u equals 0 when k equals max, then that would mean that u is max when k equals 0. So that would tell us that u would be equal to 0.39 joules when k equals 0. And our graph of u of x is going to be basically a vertical flip of our kinetic energy curve, but we're going to shift it down because u equals 0 and x equals 0. So what this is telling us is that this point right here is going to become the peak of our u of x graph. And then our points at negative 0.15 and positive 0.15 are then going to be above the x-axis. This question is so much easier to answer if you actually plot u of x first, but that's not the order they gave us. And so to me, what that means is the difference between this 0.14 that we had for kinetic energy and 0 is going to become the same difference between the peak of our u of x graph and the value of u of x at 1.5. So now let u of x be 0 at x equals 0. And so instead of u having that value of 0.39, we're basically going to subtract the 0.25 joule difference here. And we can then say oops, that u of negative 1.50 is going to be equal to a positive 0.14 joules. And now finally, we are asked to sketch u of x. So give me just a moment. I took this image of our kinetic energy curve and simply flipped it over across the horizontal axis and then put on a new x equals 0 axis. Let me grab a screenshot. So here is what u of x is going to end up looking like. Like I said, it's as if we flipped our kinetic energy curve and then shifted it down so that here is y equals 0. So and that's because we're assuming that k plus u equals a constant. And, you know, you didn't have to plot points, but you could more or less sketch things, sketch that shape if you wanted to. And now we are asked, at what values of x is f equals 0? Well, we need to remember for this part that we can find f of x with negative du of x dx. So our force is found with the negative derivative of our potential energy function. So f will be 0 when du dx equals 0. And that's going to occur at our local minima and maxima. So it's going to occur at x equals, oops, there we go, x equals negative 1.0, 0, and positive 1.0. I realize I don't have an x scale, but it's the same scale as our kinetic energy graph. And now, for what range of values is f positive? So f is positive when du dx is negative. So du dx is negative from x equals negative 1.5 to 1.0 meters. It is negative from 0 to, negative 1.5 to negative 1.0, right? It's like in this range here. And then from 0 to positive 1.0 meters. And likewise, f is going to be negative when du dx is positive. So from x equals negative 1.0 to 0 meters, and then from 1.0 to 1.50 meters. And last but not least, we're going to release our sphere from rest at x equals 1.3 meters. Negative 1.3 meters. My apologies, I missed a negative. So that's going to be our point right here. Hopefully it's showing up blue enough right there. That's 1.3 meters, negative 1.3 meters. And we want to know, what is its largest position? So here's the thing. Since we are releasing from rest, our kinetic energy is 0, and our potential energy at negative 1.3 equals the maximum we can have. So our sphere will go as far to the right as it can when the values of our potential energy do not exceed this value. So and let me see. So we thought that that value, reading off, using the kinetic energy graph to help me find it, that gave me a value of negative 0.13 joules. So for any value where our potential energy is less than that, and again, I use the values on the kinetic energy graph, and then this idea of subtracting 0.14 and then making them negative. So basically our U values. I'll make that note for you here. So subtract 0.14 from our kinetic energy values and then make them negative. So that means, and I realize my grid lines are a little bit off, but this value here is negative 0.5. So we're going one data point before that. So our maximum X is going to be negative 0.6 meters. So our sphere simply doesn't have the energy to get beyond that. And what is its largest kinetic energy? Well, the largest kinetic energy is going to be when U is a minimum. And that's going to be at negative 1.0 meters. And again, finding those values, we are using our kinetic energy graph. Let me scroll back up so we can look at this. So we are more or less subtracting 0.27 from our existing graph to use this idea that we can get our kinetic or our potential energy values by subtracting 0.14 from the kinetic energy values and then making them negative to figure out our Kmax when U was a minimum. We'll take our 0.39 minus 0.27 and we will get 0.12 joules.